10.2d, we're going to construct and interpret a confidence interval to compare two means. Now, the test statistic for this, we can either look at the z statistic or we'll look at the t statistic. It works like it did just back in chapters 8 and 9. Remember, when it comes to the means, if we know the standard deviation of the population, we use the z. If we do not know the standard deviation of the population, we use the t. The whole point of statistics is that we don't know it, so in most times than not, you're going to use the t. Let me show you, though, how they're very similar. What we're going to do for the statistic is we're going to take the difference of the two means or the samples as our sample statistic, subtract from it what we think the difference of the two populations are for the means, and then down here is the combined standard deviation of that, assuming we know our sigmas. Now, if it's a t, it's very similar. We're still going to find the difference of our two samples, and we subtract from it the difference of our new mean, or what our new mean is. Now, instead, we're going to use the actual sample standard deviations and combine them to get the new one. As we said earlier, why do we use t rather than z? When the population standard deviation is unknown, we absolutely use the t statistic. One thing you do need to remember is how to calculate the degrees of freedom. The t statistic uses the degrees of freedom and not the sample size. What you're going to do for the degrees of freedom, because there's two samples, is you are going to take the smaller of the degrees of freedom. You're still going to calculate it as the first sample is minus 1, and then take the second sample minus 1. Whichever one is smaller would be your degrees of freedom. That's a conservative approach to use it. So the formula for the confidence interval, when you have to find the difference of two means, what they're going to say here, we need to make sure the conditions are met for the confidence interval, and that we have two independent groups. So we will have to check for independence. We will check for normalcy and also talk about randomness. But the interval is this. We're going to take what it says in the formula sheet, our statistic plus or minus our critical value times the standard deviation. Well, the statistic we know is just the difference of the two means. We are going to have to find the t critical value using the t table or inverse t in the calculator, and then we're just going to use the standard deviation for the t distribution. Recall that when you need to find the t critical value, or really how many standard deviations we're talking from the mean, we're going to use inverse t in the calculator, which just asks you for the area and the degrees of freedom. If you forget, the calculator will always remind you when you look at the screen. Let's go ahead and do a confidence interval for the difference of two means from start to finish. Here we have plastic grocery bags. Do plastic bags from Target or plastic bags from Basha's hold more weight? A group of AP Stats, the students decided to investigate this. They did a random sample of 5 bags from each store, and then they filled them until the bags ripped. The weight of the contents were then recorded, and here's what we have. So the Target bags, the Basha's bags, and it was done in grams. Construct and interpret a 99% confidence interval for the difference in the mean capacity of the grocery bags from Target and Basha's. So we want to estimate, we want to decide if it's going to be Target minus Basha or Basha minus Target. It doesn't matter as long as you're consistent. Let's just go ahead and say we want to estimate mu of t minus mu of b at a 99% confidence level. And let's define the two variables. So the mean capacity of Target and then the mean capacity of Basha's, both in grams. For the plan component, let's talk about what we're going to do. If conditions are met, we're going to calculate the two sample t interval for the difference of mean of t minus mean of b. And that's all you have to say. Randomness for this was met in that students selected a random sample of bags from each store. The normalcy in here, now we have to be careful. We're doing t procedures. Our sample size was 5, which is incredibly small. So since the sample sizes are small, you must graph the data to look for the distribution if it's approximately normal. Remember, we're looking for no obvious outliers and little skewness. So here's a dot plot of the weights in grams of both Target and Basha's, and it's a combined dot plot. There really is little skewness and no outliers to here, so it's safe to use the t procedures. Now in this case, we are sampling without replacement. So the samples were selected independently, and it's reasonable to assume there's at least 50 plastic bags in each of the two stores. We walk through the do portion doing both the manual calculations and the calculator format. So first, manually, what I would do is put all the data in list 1 and then in list 2. Do a 1 variable stat on target bags and a 1 variable stat on Basha bags. If you do that, you will get the corresponding mean and standard deviation for target and that for the Basha bags. Now, the degrees of freedom we need to use, because for a confidence interval, we must come up with a T star. Sample sizes were 5 for each, so 5 minus 1 would be a degrees of freedom of 4, and that's what we would use. So we want to find the critical value at a 99% confidence. Let me just reiterate again how to do that. Remember, we want to be 99% confident, which is the main area here, which leaves 1% left over, so there's a 0.5% in each tail. So we really want to find the area under the curve at 0.995. And then we use inverse T because that gives us the T critical value at 4 degrees of freedom. And you get a critical value of 4.406. Now if I just put the information I need into the actual formula for the confidence interval, what we're going to end up seeing is this right here. It's going to be our mean of target minus mean of Basha plus or minus our critical value. What we're seeing here now, be careful, this is the standard deviation. It's being squared over our sample size for both of the two conditions. When you simplify this, you will end up getting your confidence interval will be the weights between negative 1380 grams up to 8564 grams. Now, what if you want to use the calculator for this? Couple of things to be cautious of. First thing, let's look at the calculator screens. On the calculator screens, you are going to go to here. Go Stat Edit, but go to Tests. We're looking for the 2 sample T interval. So 2 sample T interval. Now you have a couple options. You can either enter the data or you can compute your statistics first and then enter that. The data on this works actually quite well. If you select the data, you have to have your data in list 1 and list 2, and you say where the data is and you enter it accordingly. I'm just going to hit stats since I already have the statistics up here. And all at once is the mean of sample 1, standard deviation of sample 1, and the sample size, and the same thing for sample 2. You do want to do the confidence level. Be really careful for this next thing. They say pooled yes or no. Pooled is just for proportions, and we're never going to select this, so just make sure it always says no. Hit calculate, and you're going to get this. Now, you're going to notice that the confidence intervals we've computed are actually quite different in between these two. What you're going to see with the technology is that the degrees of freedom is at 7.5, and the confidence interval is actually different. Notice how much narrower this actual interval is than the one by hand. This one is being conservative with our degrees of freedom. The calculator actually computes the more accurate degrees of freedom. You can use either method. If you use the calculator method, do not write down degrees of freedom 4 because that's not what you're using. Literally just copy down what you're seeing on this screen. Write down the interval, degrees of freedom, and all of your samples, means, and standard deviations. And then you should just be fine to be covered for calculator speak. Let's wrap up the conclusion, and I'll just use the manually calculated data for a conclusion. So we could say that we are 99% confident that the interval from negative 1,380 to 8,564 grams captures the true difference in the mean capacity for grocery store bags from Target to Bashas'. Let's wrap it up with this. Does your interval provide convincing evidence that there is a difference in the mean capacity among the two stores? By the way, it doesn't matter if you use this manually calculated interval or the calculator one, you'll make the same conclusion. Is there a difference? If there wasn't a difference in the mean weights, then the difference of 0 would have to exist in this confidence interval. Clearly we see that 0 is a possible answer for the interval. Therefore, since the interval includes 0, it is plausible there is no difference in the two means. Therefore, we do not have convincing evidence that there's a difference in the mean capacity. Now, we might want to be cautious here and make this statement. However, if we increase the sample size, we would likely find a convincing difference since it seems pretty clear that the target bags have a bigger capacity. And here our sample size is really limiting our ability to make a good conclusion. But our gut tells us otherwise because the data really seems striking. So maybe we do this investigation one more time with a larger sample size to see if it really will hold.